Hello everyone, welcome back to another video. In this video, we are going to talk about the black hole formula. So this will be the part 2 of the black hole. So let's begin. Number 1. Schwarzschild Radius formula. It represent that the size of the black hole, how much the radius of the what should be the required radius for the mass of the object to become it to compress it so that it becomes a black hole. If formula is written that Rs, it's the radius, 2 gm. So 2 is the only number 2 which is multiplying with the gm. G is the gravitational constant. M is the mass of the object, and c square we already know that it's the speed of the light square. So let's start. So first we are going to talk about the sun. Uh, Talk about the sun. So its gravitational constant is 6.674 into 10 raised to power minus 11 Newton, minus 11 Newton per kilogram square. This is the quad um, quadrant square is you can say it's represent multiplication. It represent multiplication. So basically it's the, let me write over here. So the gravitational constant equals to 6.674 into, what's the sign, into 10 raised to power 10 raised to power minus 11 Newton, sorry, N capital, into kilogram power square power 2. So it's basically this. So I am using word because on PowerPoint presentation we couldn't write the formula like this. So it's the mass of the sun. Mass of the sun is 1.989 into 10 raised to power 30 kilograms. It's too much. Now this step 1, put the values. After we do it, the multiply numerator. After you this will after you do it, it will be 2 into 6.674 into 1.989. Okay. After that, after solving this thing, we will get 26.54. 26.54, it's the numerator. And here minus 10 raised to power minus 11 and 10 raised to power 30 equals to 10 raised to power 19. So there is also 10 raised to power 19. It's like 10 raised to power 19. And after that, our numerator become 26.54 into 10 raised to power 19. Now let's solve the denominator. It's the speed of light square, so it will be 9 into 10 raised to power 16. 9 into 10 raised to power 16. Now this step 4, keep the values. And now the radius would come 26.54 into 10 raised to power 19 into divided by the 9 into 10 raised to power 16. So it will only remain the 10 raised to power 3, and it will be 2.95 into 10 raised to power 3 meters. So the sun would be compressed into the radius of 2950 meters, which is 2950 meters. Therefore it is approximately 3 kilometers. So if the sun was compressed into the sphere of the radius of 3 kilometers, it would become a black hole. What it would become? It will become a black hole. Now the escape velocity formula. It's similar to the Earth's escape velocity. Example Earth. We will take the example of the Earth. Now under root, R is the radius of the Earth. R is the radius of the Earth. V equals to the escape velocity. This is the sign of under root. And under root we have the 2 into gravitational constant into the mass divided by the r. R is the radius, and the mass of the. And now let's talk about the given. The gravitational constant is 6.674 into 10 raised to power minus 11, and the mass is 5.97 into 10 raised to power 24 kgs only. I am saying only, but it's not only. It's too much. Now putting the values. V equals to the under root 2 into 6.674 into 10 raised to power minus 11 into 5.97 into 10 raised to power 24 divided by the 6.37 into 10 raised to power 6. So let's solve the numerator first. When you will solve the numerator, 10 raised to power, you have to subtract its power from this power. So it will be 10 raised to power 13 only. So 2 into 674 into 5.97, which will give the value of 79.68, which will give the value of the 79.68. After you get the tens power, you have to multiply it with this. So in this step 3, you will take the value equal. You will take the value equal and divide it by 6.37 into 10 raised to power 6. After you divide 6 will be subtracted from the 13. It will be 10 raised to power 8. 1.25 into 10 raised to power 8 will be the answer. And after you square root of the 10 raised to power sorry, under root 1.25 into 10 raised to power 8, you will simply get 11,180 meter per second, which is 11.2 kilometer per second, which is the actual escape velocity of the earth. Now deriving a black hole. Driving a black hole. Do you know that basically it's the escape velocity of the black hole, but we have to keep VE. We have to replace VE by C. For removing the square over here, this is its formula. It's in like the escape velocity formula we discovered in the Earth escape velocity. After you do it, it will be the c square into 2 into gm over r. We have already discussed this formula, so we won't discuss it anymore. So let's talk about the fourth formula. There are total 5 formulas. The fourth formula is the black hole density. So the black hole density formula is that P equals to m divided by the V, volume of the sphere. V equals to the volume of the sphere, which is equals to V equals to 4 divided by 3 pi r cube. R cube. Assume mass equals to 10 m, radius equals to 30,000 m. Step 1, V equals to 4 divided by 3 pi into the 30,000 cube. So after you solve it, you will get 1.13 into 10 raised to power 14 meter square, meter cube. So the mass will come out to be this, which is approximately 2 into 10 raised to power 31 kgs. And step 3, you have to 1.989 into 10 and into 31 divided by 1.13 into 10 raised to power 14. So the P equals to 1.76 into 10 raised to power 17, and P equals to 1.76 into 10 raised to power 17 kg mass. It will be the mass of the black hole. It is the mass of the black hole, and that's a numerous density. Sorry, it's the density, not the mass. Sorry. Last one. Last one is the Hawking temperature. So this is a long formula, and this video is already 10 minutes. If I will talk about the Hawking temperature, it will take around 20 minutes more. So we will discuss about the honking temperature in the next video. So if you liked my video, please hit the subscribe button below and press the bell icon so you receive my latest video first. And please like my video and I will meet you in the next one. Till the time, bye bye.